Okay, welcome America, welcome Taylor Swift to our recording today in Studio 212. Today we are going to be graphing reciprocal functions. We're going to be doing problem 1 on the worksheet that I hope to attach. So this is a secant graph. So what's the reciprocal function to secant?
Cosine.
Okay, so we are going to first start by rewriting this original equation instead of secant as cosine and plot the cosine points. So let me start with that. Y equals -2 cosine theta over, they're just using theta instead of x, theta over 2 minus pi plus 1. All right, so what's the amplitude?
2.
Okay, 2. It's the absolute value of -2, right? So what is the period? This is the same thing as 1/2 theta. So b is 1/2. So the original period of the parent function is 2 pi. So it's 2 pi, oh my gosh, that's a pi, divided by 1/2. We never divide by a fraction. We always multiply by the reciprocal. So what would that be? 4 pi. Which makes the unit what? What are we counting by? Right, divide that by 4 pi. So let me come over to my graph and document that we are counting by pi. That's a pi. Okay, phase shift. I'm going to go ahead and set, let me do this over here. Theta over 2 minus pi equals 0. So theta over 2 equals pi. And you can, a lot of people have trouble simplifying this because we're trying to isolate the theta, but really you can just think of cross multiplying like you mentioned last class, or you can multiply both sides by this 2. Either way, you're going to get theta is 2 pi. And that's positive. So we have a phase shift of 2 pi. And I'm going to, since I'm not putting a plus in front of it, that just assumes it's positive. But you can write plus in front of it if you'd like, okay? We've got a vertical shift of up 1. So while I am remembering, sometimes I forget to do this, for my vertical shift, I'm just gonna put a horizontal highlighted line up, so I remember to move my points up. And then my phase shift is gonna be, we're gonna go right 2 pi, and we're counting in pies. So we're gonna be going over 2 units. So our new location of our 0, 0 is right 2. Right 2 and up 1. Right there. So that's our new 0, 0. Now, that point is not going to be on our graph because we're graphing cosine. And if it was a sine function, that 0, 0 would be on our graph, but it's a cosine function, and cosine starts high. Right? This one is a negative cosine function, so it's going to be starting low, and the amplitude is 2. So from that 0, 0 point, we are going to be going down 2, 1, 2, right there. And we're starting low because of the negative. Is everybody comfortable with that? I'm going to go ahead and, Drew? When we solved, we got a, did I miss a negative somewhere? We got a positive 2 pi. Had we received a negative 2 pi, then it would be going to the left, pi over 2. I think you're thinking of, just to simplify it, if I had, the sign of, x minus 2. In Algebra 2, we learned that it's the opposite direction. So this would be a phase, this would be a shift right 2. But that's just because if you set x minus 2 equal to 0 and then add 2 to both sides, you'll see that x is a positive 2. So it's really what goes in here to make this equal to 0. So this would be a shift of 2 to the right, even though it's a minus 2. That's what I think that's what you're thinking of. Oh my gosh, I'm psychic. Okay. Okay. Where are we at? Okay, so now we've got our starting point. So from there, I'm gonna just plot my points in. I'm not gonna draw the graph, I'm just gonna put the points on the graph. So low, 0, high, 0, where am I? Low, 0. I have to be careful when I do this, especially if I don't draw that vertical shift on my graph. I get confused. So, but this is good. Low, 0, high, 0. Now, what's the next step for a reciprocal function? Because if we were actually graphing a cosine function, we'd be done. We'd just draw the graph. But this is the reciprocal. So what's going to happen to those zeros? What? They're going to be undefined, which makes them asymptotes. So let's go ahead and draw the asymptotes in. I'll use a green highlighter. Now, all my zeros are on this new highlighted line here, so I'll start here. I'm trying to draw them dotted, but this board is so sensitive. There we go. Good enough. And now, I'm going to use red and just have my graphs approaching the asymptotes. Beautiful. Love it. Is Friday night going to be brutal or what?
Yeah. With 55 is
They're number 1 right now
Yeah.
in 4C.
Yeah.
All right. Domain. X cannot be, the first asymptote is at pi. So X cannot be pi plus half the period, because the next asymptote is at half of the period. So half the period is 2 pi. So pi plus 2 pi k, because we've got another asymptote. If I add 2 pi and then I add 2 pi again, there's another asymptote. If I add 2 pi again, there's another asymptote. If I subtract 2 pi, I get another asymptote. If I subtract another 2 pi, I get an asymptote, k times. So it can't be pi plus 2 pi k. And the range will be from negative infinity up to, is that a -1? Including -1, that's on our graph, in union with, I have to use a different color here so you can see it, 3 to infinity. Did I leave anything out? Good? Thanks for coming out.